you're prolonging the bleeding time. Maybe you're moving it toward normal or optimal, and what's normal in America, it's like a normal cholesterol. Nobody wants to have a normal cholesterol. Maybe you don't want to have a normal bleeding time either. Anyway.
Very good.
I digress.
I think very interesting point. And I'm sure you're aware of this, but there have been some studies on omega-3 playing a preventative role in pulmonary embolisms.
Sure. So that would play that role too, right?
Right.
That would suggest that they're beneficial in that regard.
Yeah.
Yeah.
So maybe we could take just a step back for a moment, and because omega-3 fatty acids, there's 3 of them, and most of the time I'm focused when I think about my enthusiasm for omega-3, I think about the marine sources.
Yes.
Of EPA and DHA, but there's another source, ALA. Do you mind just spending just a brief moment kind of?
Sure. Yeah, so right, so we generally put them in 2 camps. There's the plant-based omega-3s and then the fish, seafood-based omega-3. And alpha-linolenic acid, ALA, is the 18-carbon omega-3, 18 carbons long, omega-3 compared to the 20 or 22 carbon long marine omega-3s, EPA and DHA. And they are all in the same chemical family, as you say. They're classified as omega-3s because they have a certain chemical structure. But they are not, it's like, third and fourth cousins. They're, in my view, the ALA has not got the cardioprotective benefits of EPA and DHA. I mean, there's some studies that have shown some benefit, and it's good. I'm all for it. But people very often confuse those 2 sources. They think they'll list good sources of omega-3. They'll say salmon and sardines, then they'll say chia seeds and black walnuts, and just throw it all in together, and it's very misleading because the plant-based omega-3s are not nearly as potent as the marine omega-3s.
So the plant omega-3s, ALA gets converted into EPA in the body, correct?
It can be, yes.
It can be, and this is one reason why, when you look at the essential fatty acids, you see ALA on there and not EPA and DHA, yeah. Correct?
Correct.
Which irritates me, but
well, you're not alone.
Yeah. And so, is there any? We can talk about also like the conversion of ALA into EPA and DHA there's huge inter-individual variation in terms of like how well people do this.
Huge might be a strong word for it. There is certainly inter-individual, but it's not like some people convert 1-to-1 and other people are, 0.1%. It's not that big,
okay,
but it's, in the neighborhood of, it's in the neighborhood 2, 3, 4, 5%, of ALA going to EPA. ALA going to DHA is less. I mean, for the EPA that's produced doesn't go on to DHA. So it's not a good source of DHA for sure.
Do you think does the literature suggest there's any benefit of ALA that can be separated from its, ability to be converted into DHA?
It could be, and there's some studies that could be interpreted that way. And there certainly are. I mean, ALA can be converted we'll talk about later, into a variety of what they call oxylipins. These are oxygenated fatty acids. Prostaglandins are the most common ones you think of. But those are 20-carbon fatty acids. But there are metabolites of ALA that are made via these enzymes that we don't know what they do, but they're there. They're made for a purpose. So there may be benefits that come from them as well, independent of a conversion. So that's, I think, future research to figure that out.
What do you think the best source of the omega-3s would be for someone who is a vegetarian or a vegan?
Vegetarian or vegan would be an algal oil. So the original source of EPA and DHA in a fish is not that they make omega-3. They don't really make omega-3 any better than we do, or make EPA and DHA. They eat preformed EPA and DHA, and it comes from their food sources, which at the bottom of the food chain is these single-celled microalgae. And I'm not talking about seaweed. these little organisms that convert sunlight into fatty acids, some of which are omega-3. And so different companies have identified which strains, specific strains of algae, microalgae, will make DHA or EPA or both. And they've commercialized or they industrialized it and they harvest the oil. It's an expensive process at this point. I think what's exciting is that if we can get over the GMO issue, which is a whole other question, but there are 2 or 3 groups that have found ways to put genes into plant or land plants that can be grown. As long as you've got ground, you can grow them. Camelina is one. Even soybean oil, which starts with ALA, you can get up to a fair amount of DHA, EPA and DHA with genetic engineering of these plants. So someday we could be to the point, if we will accept that GMO-produced omega-3 and not be weird about it.
It sounds more sustainable.
Totally sustainable. Yeah. You don't have to kill any fish to get omega-3s out. And that's, I think, in the future. We're doing it now with the microalgae, but that takes huge vats and lots of processing after the algae are grown. But if we could do it with something on the scale of soybean oil, God knows we could have huge amounts.
That's very exciting because it's an important question that many people are asking. The taking of the fish oil, and we'll get to supplementing with fish oil, but how it's not sustainable, and people are concerned, and I think rightly so.
Rightly so. I mean,
it is.
Sure. If we really attended to the recommendations that everybody gets, say 500 milligrams a day, there's not enough fish in the ocean to do it, and aquaculture is not going to do it. So there has to be a new source of it.
Right. And
there will be. Demand will drive it. And hopefully we'll again, get over the concern about it being a GMO product.
Right. I mean, I'm certainly not concerned about it.
You and me both. Okay, well, there's 2 of us.
I want to discuss a seminal paper, what I think is a seminal paper of yours that you published back in 2004. Mm-hmm. You co-published with Dr. Von Schacke about the omega-3 index, and the omega-3 index being an important risk factor for cardiovascular disease.
Right.
Can you